Okay, here we go. Figure out how to turn this off. Not a clue. Okay, so welcome to two viewers. One of them might be me, so that might just be one of you out there. So whoever you are, and I can't tell, I'm going to be going through a few things today. So yesterday I started doing Pythagoras, just a bit of general revision, and then the connection cut off. So have another look at that. Fractions, adding and subtracting mixed fractions. So I did a bit about fractions on Monday. I'll do a bit more of that. And then if you've got any requests at all, just email me. So you know the school email address, jjc at, and then you know how the rest of that goes for the school. I'll have my email on ready to see anything that pops up. So if you've got something you got stuck on iMaths, for example, you can send me a screenshot. Okay, nothing there yet. Okay, so I'm going to do a bit of Pythagoras work, I think. Let's just put my little schedule underneath there. So, Pythagoras. So as I started mentioning yesterday, before it cut out, I first started teaching Pythagoras in early MYP3, but certainly it's straightforward enough to be able to understand it earlier on. So MYP1 and 2, if you're out there, certainly worth listening to. It's not that hard. So right angled triangles, 3 sides and a right angle, a 90-degree angle, and then the 2 shorter sides, I'm going to call them A and B, then the longest side. Now the longest side is always kind of opposite from the 90-degree angle, because the 90 degree is always going to be the biggest angle, since there are only 180 degrees in a whole triangle. So the longest side is always going to be the one opposite the 90 degrees. So that has a special name, the hypotenuse. I'm going to call that H for short. And Pythagoras' theorem says that a squared plus b squared equals h squared, the hypotenuse squared. Now you sometimes see that written as c, so they label the longest side c, and they say a squared plus b squared equals c squared. And when I was at school, I had to learn that in words as the square on the hypotenuse is the sum of the squares on the other 2 sides, which is a bit of a mouthful, and certainly a squared plus b squared equals c squared or h squared, whatever you want to call it, is a lot easier to remember. So what does that mean in real terms? Let's just come up with some actual example questions. Now the thing is, with Pythagoras, there are only 3 questions that you ever get asked. So the first type of question is, let's draw a random right angled triangle. Now in fact, let's measure it exactly. So this is 6.5 centimeters, and I've just drawn it randomly. That's 4.5 centimeters. And I'm going to call the longest side H. I know it's the longest side because it's opposite the 90-degree angle. And I want to know what H says. So Pythagoras' theorem says that the longest one squared is equal to the other 2 squared, and then added up. So all of that on the right hand side is something I can work out. Oh, I've got a question from someone in MYP4. I'm currently unable to log into iMaths. Okay, well I'll deal with that after this. So don't worry about that. Okay, so let's get my calculator up on this slightly useless iPhone. And let's put that there so we can see it, and turn it around so I get the scientific calculator. Okay, so 6.5 squared means 6.5 times itself. It doesn't mean 6.5 times 2. So 6.5 times 6.5, top of my head, is that 42.25? Yes, it is. Brilliant. Brain's working. 42.25 plus 4.5 squared. 4.5 times 4.5. Oh, is that 20.25? Yes, it is. Wow. 20.25. So h squared equals 4.5 squared plus 6.5 squared. This squared equals this squared plus this squared. And that all comes to, let's add them up, 62.5. So h squared is 62.5. So remember, squared means times by itself, multiplied by itself. It doesn't mean times 2. People often confuse those. So if you know what something squared is, and you want to know what the thing is on its own, then what we need to do to both sides of that is to square root both sides. So if I just take the number, let's just clear all that, 62.5, and press my square root button, it's about 7.9 centimeters to 2 decimal place, to 1 decimal place, 1 dp. So let's underline my answer neatly. 7.9 to 1 decimal place. And of course, the good thing with this is I can actually measure that to check that makes sense. And there it is. I mean, taking into account that I've got a pen where I'm drawing lines that are a couple of millimeters thick, you can see that 7.9 is pretty well on the mark. So that's good. That all worked. So that's one kind of question you get when you're doing Pythagoras, where you're finding out the missing side, and the missing side is the longest one. So second kind of question you can get is where you're working out the missing side, but it's one of the shorter ones. So again, let's draw a random thing here, and let's do it like that. And this time I'm just going to measure the hypotenuse, and it's about 10.5 centimeters. Doesn't matter which one of these I do, but let's measure the base, and that's 8.5 centimeters. And then the missing side is, so we need to label it with a letter. Let's call it Steve. Why not? So Pythagoras' theorem says that Steve, as I've called that missing side, squared plus, right angle in there, by the way, plus 8.5 squared equals 10.5 squared. So it's the two smaller ones squared add up to the bigger one squared. But I've just noticed someone gave me a thumbs up and then a thumbs, and then undid it and then thumbs up again. What's going on there? Somebody keeps pressing their thumbs up and down buttons. Anyway, yeah, so the two smallest ones squared are together, adding up to the biggest one squared on its own. So this time, the thing that we are looking to work out is getting squared and added together with some other thing. And then the longest side, the 10.5, is the thing that's on its own on the right. So anyway, calculator on that. 8.5 times 8.5 squared, 72.25 is 8.5 times 8.5. And then 10.5 squared, 10.5 times 10.5 is 110.25. So Steve squared plus 72.25 equals 110.25. So I'd like to get this bit on its own, the bit that is the unknown side, Steve. So what I'm going to do is take away the 72.25. But because an equation is like a balance, whatever I do to the left-hand side, I also have to do to the right-hand side. So I have to take away 72.25 from the other side as well, leaving me, can I do that in my head, 38. 38 exactly. So having taken away 72.5 from the left and 72.5 from the right, 72.25 rather, having taken away 72.25 from the left and 72.25 from the right, I end up with Steve squared equals 38. So Steve itself is the square root of 38. So I'm square rooting both sides. And let's just get the calculator on that. So clear everything. 38 square root 6.16. I'm going to round that to 6.2 centimeters to one decimal place. Neatly underline my answer. Note how everything is lined up vertically so that you can follow the working and see where everything comes from. Let's just check whether that was right. So that should mean that the triangle is 6.2 centimeters high, and lo and behold, that's pretty well right, bearing in mind that I'm using a very thick pen, so that's going to make me a little bit inaccurate. Okay, so that's two types of questions that you frequently get with Pythagoras. You'll either get a question where you're figuring out the longest side, and then it's the two shorter ones squared that add up to that, or a question where you're trying to figure out one of the two shorter sides, then it's the shorter side that you're trying to figure out together with something else adding up to the square of the longer side. One third question that you can get is they give you all three of the sides and they ask you, is the triangle right angled or not? So let's just say we have a another random triangle there, and then let's say that another random triangle there, and then let's say that that's 8 centimeters, because it is, and let's say that the well, it looks like about 9 centimeters. So let's say that in some triangle, sorry, I just have to readjust my seat. There we go. So in some triangle, the three sides are 5, 8, and 9. Now, the way I've drawn it, it looks right angled, but the question is, if I were to accurately construct that, get my compass out and start drawing an actual 5, 8, 9 triangle, would it be right angled or not? Okay, well, it'll be right angled if Pythagoras' theorem holds true. So 5 squared plus 8 squared is 25 plus 64, and that's 89. But 9 squared is 9 times 9, which is 81. So 89 is not equal to 81. So it's not right angled. And in fact, because we wanted the 5 squared and the 8 squared, well, because the 9 squared is 81 and the 5 squared plus the 8 squared is longer than that, that means that the 9 is shorter than it needs to be to make the triangle right angled. So for that to be a right angled triangle, then the square of the hypotenuse would have to be 89, the same as the square of the other two. So that 9 is a little bit too short to make it a right angled triangle. So because the 9's a bit too short, that means that the angle in there is actually less than 90 degrees. So if I draw that accurately, I should see that that's less than 90 degrees. So that's called the converse of Pythagoras' theorem. And well, I might as well try and construct that. So let's get my thing here, 8 centimeters. 1, 2, 3. I don't need to get it at 8 centimeters actually, because I can just draw 8 centimeters. Being a bit silly there, aren't I? So let's get a more accurate pen there and draw an 8 centimeter line, which takes me to there. And then let's get the compass at 5 centimeters. 1, 2, 3, 4, 5 centimeters. So 5 centimeters from that end is anywhere on that arc, because I've set this to 5 centimeters. Now let's try and draw the 9 centimeters. So I'll set my compass to 9 centimeters. 1, 2, I'm just using the squares in the book because they're half a centimeter each. 1, 2, 3, 4, 5, 6, 7, 8, 9 centimeters is there. So if I draw an arc 9 centimeters from there, so where those two arcs meet up give me something that's 5 centimeters from the one end and 9 centimeters from the other end and 8 at the bottom. And then hopefully you can see that indeed, as I predicted, when I constructed that accurately, the angle down there was not right angled, but in fact it was less than 90 degrees. So those are the only 3 questions that you ever get asked about Pythagoras' theorem, really. So given that it's a big important thing in the history of maths, it's quite easy to get to grips with because there are only ever 5 questions. Sometimes they draw the triangles the other way around. So for example, this here, that's a right angled triangle. But so the way I've drawn all the triangles so far today, they've been that way up or that way up or that way up. But you sometimes see a question where you get the right angled triangle, the right angle in the triangle at the top there to confuse you. But you've just got to realize that the longest side is down there and the 2 shorter ones are up there. Okay, so that's enough Pythagoras for today. At this point, I will just check my mail, see if anybody's got in touch with any questions. Excellent. Okay, so I've got a question from, well, I'm not going to say names because this is kind of in the public domain. So since anybody could be watching, for your own protection, I'm not going to mention specific names. Sorry for being late. I don't need to how to solve this because it is negative. Can you explain live on your YouTube channel, please? Well, okay, so 8p minus pq minus 7r. You're going to need to give me more information because I don't know what the question is asking you to do with that. It could be some kind of factorizing thing, or it could be figure out what this is worth when p and q and r are certain values. So if you can send me another mail, if it's a factorization problem, then it might be that you need to take the p out of that. So because both of these divide by p, then you can take a p out of the brackets. P times 8 gives you the 8p. P times minus q gives you the minus pq. And then the 7r is on the end and you can't factorize it. Oh, you can't take any factors out. So, I mean, if it is a factorization question, there are no common factors to 8p or pq and also 7r. So that could be the answer if it's a factorization question, but you need to let me know more about the question. Is it a factorization, or is it another viewer? Excellent. Or is it a figure out the value of it when p, q, and r are certain values that they give you? So maybe if you give me more of that, mystery person, then I can do more with it. Or maybe that's answered the question. Or maybe there was another p in there that you forgot to write. That could be another possibility. Okay, fractions. So I mentioned a bit about fractions on Monday for MYP1. So I first teach fractions in MYP1, and you should be familiar with it from a little bit from PYP anyway. But it's something that all the way up to adulthood, people kind of forget how to do. So I'm going to do a bit of mixed number work. So let's say 3 1/3 plus 2, and randomly let's make it 2/5. Okay, so what I like to do with these mixed number ones is to split it up into the number bit, so the 3 plus the 2, and the fraction bit, so the 1/3 plus the 5th. So 3 plus 2 is simply 5, and 1/3 plus 1/5, I can't do anything with that yet until I've made the denominators the same. So 3 and 5 both go into 15. So I'm going to multiply 1/3 by 5/5 to make it into 5/15. And then I'm going to multiply 1/5 by 3/3 to make it into 3/15. So the idea of that being to make the denominator the same in both. Remember, I'm not multiplying by 5 or by 3 here. I'm multiplying by 5/5 and 3/3, which is just like multiplying by 1. So I'm not making the numbers any bigger or smaller by multiplying by 1. I'm just writing them in a different format. Okay, so we got 5 plus 5/15 plus 3/15. A message about the last one. Yes, it is a factorizing linear, factorizing with letters. Okay, so if the question was, as you said, mystery person, let's call them E, then the answer I put up there should do it for you. Certainly, if that's from iMaths and you're not getting that right, maybe send me a screenshot so that I can have another look at it. Okay, so 3 plus 2 is 5. 5/15 plus 3/15 makes 8/15. So add up the tops, the bottoms stay the same. So 5 plus 8/15 is 5 and 8/15. 8/15 doesn't simplify, so that's the final answer. So that's your kind of basic example with adding mixed numbers. I'm going to have to buy another one of these pads soon, I think. Another 10 kroner. Okay, so trickier example. 11 and let's say 4/5 plus 4 randomly, and let's say, struggling to think of a number now, let's say 11/15. Okay, so first of all, I'm going to split up the whole numbers from the fraction part. So 11 plus 4 plus 4/5 plus 11 fifteenths. So 11 plus 4 is 15. And then 4/5 and 11 fifteenths. So I want to write both of those as fractions out of the same number. And then 5 and 15 both go into 15. So I can leave 11 fifteenths as it is. But then 4/5 I can multiply by 3/3, which is really just like multiplying by 1, and turn it into 12 fifteenths. So I've got 15 plus 12 fifteenths plus 11 fifteenths makes 23 fifteenths. And the problem with that is that 23 fifteenths is a, well, there's lots of words for it: top-heavy fraction, a vulgar fraction, an improper fraction. There's more on the top than on the bottom. So I'm going to take that 23 fifteenths and I'm going to say 15 goes into 23 one time with 8 left over. So 23 fifteenths is the same as 1 and 8 fifteenths. So I've got 15 plus 1 and 8 fifteenths makes 16 and 8 fifteenths. And 8 fifteenths doesn't reduce, so that's that one there. And another email. Another email from, oh, that's my mistake. I see. Okay, I'm going to go back to that factorization because it turns out I've just been informed by mystery student E that I'd copied it down wrong. So in fact, all of the things had a P in them. So 7P minus PQ minus 7PR. And we're looking to factorize that. So all three of those have got a P in them. So I can take the P outside the brackets and then say, what do I need to multiply each of these? What do I need to multiply P by in order to get each of these terms here? So P times what will give me 8P, that's an 8. P times what will give me the minus PQ. So minus Q there, P times minus Q will give me the minus PQ. And then P times what will give me the minus 7PR. So P times minus 7R will give me minus 7PR. Because remember, a couple of things to remember there. When you're multiplying things, the order doesn't matter. So PR and RP mean the same thing, just in the same way that 4 times 5 is equal to 5 times 4. So multiplication is what you call it, commutative, when you can do it both ways. And then what else? Yeah, and whenever you see a minus sign, it always belongs to the thing that comes next. So always remember that you see a minus, it's got nothing to do with the thing that precedes it. It kind of belongs with the thing after it. Okay, so your answer, mystery student E, should be P brackets 8 minus Q minus 7R close brackets. I hope that helped, and I welcome any more live queries like that. Back to fractions. Okay, so next thing I want to do is subtraction. So let's say 5 and 7/10, why not, minus 2 and 1/3. So I'm going to do a couple of examples with fractions. This is a relatively simple one, and then I'm going to do one where there's some kind of a problem. So again, I like to split these up into the number bit and the fraction bit. So I like to take the 5 minus 2 and add it to the 7/10 minus a third. So I like to do the number minus the number, the fraction minus the fraction. Now, sometimes people ask me at this stage, the plus in the original thing, because when you see 5 and 7/10, it means 5 plus 7/10. And when you see 2 and a third, it means 2 plus a third. So there is a plus in there. It's just that it's not written down. So I'm fully justified in writing the plus there and splitting this up as 5 minus 2 together with 7 minus a third. Okay, so 5 minus 2 is 3, easy peasy. And then 7 minus a third, I want to write that as 2 fractions out of 30 because 10 and 3 both go into 30. So in order to get from something out of 10 to something out of 30, I need to multiply by not 3, but 3 over 3 to make that into 21 out of 30. And then in order to get from something out of 3 to something out of 30, I need to multiply by not 10, but 10 over 10 in order to make that into 10 out of 30. So I've got 5 minus 2 is 3, and then 21 out of 30 minus 10 out of 30 makes 11 out of 30. So my final answer is 3 plus 11 over 30 makes 3 and 11 30ths. Final answer doesn't reduce, so that's as far as we're going with that. No more emails. And down to 2 viewers now, and one of them's probably me. I wonder who you are. Subtracting fractions with a bit of a problem. So let's randomly 28 and randomly a quarter minus 15 randomly, and let's say 2/3. So the problem with that is that a quarter minus 2/3 is a quarter is less than 2/3. So when I try and take away 2/3 from a quarter, I haven't got enough to take away because I'm trying to take away something that's bigger. And 5 quarters. So I've taken 1 out of the 27 and I've turned it into 4 quarters, so that 28 and a quarter is the same as 27 and 5 quarters. So I've got 27 and 5 quarters, as I'm going to write it, minus 15 and 2/3. And the reason for doing that is that it's made the fraction bit bigger now, so that the fraction I'm starting with is bigger than the fraction I'm going to take away. Okay, now that I've fixed that, it's going to be like any question that I had before. So I'm going to split it up into the 27 minus 15, and then add the 5 over 4 minus the 2 over 3. So 27 and 5 quarters minus 15 and 2/3. I've split up into 27 minus 15 and 5 quarters minus 2/3 over there. And again, there's a plus in the middle because, well, these things have a secret plus in the middle of them. 27 and 5 quarters means 27 plus 5 quarters. 15 and 2/3 means 15 plus 2/3. So that plus hasn't come from nowhere. It just wasn't written down before. Okay, so 27 minus 15 is 12. And then 5 quarters minus 3 quarters. Well, 5 quarters minus 2/3, I meant to say. 5 quarters minus 2/3. 4 and 3 both go into 12. So the common denominator is 12. I want to write both of these as fractions out of 12. So at the moment, I've got a fraction out of 4. I want to make it into a fraction out of 12. So I'm going to have to multiply by not 3, but 3 over 3 to get 15/12. So 5/4 is the same as 15/12. And then I've got 2/3 that I want to write it as a fraction out of 12. So I need to multiply it by not 4, but 4/4. So 2/3 is the same as 8/12. So I've got 12 plus 15/12 minus 8/12. So 15/12 minus 8/12. 15 minus 8 is 7, and the bottom stays the same. So that's the same as 12 plus 7/12. And 12 plus 7/12 is 12 and 7/12. Final answer, 7/12 luckily doesn't need to reduce. Oh, it's a question from mystery student R. Why's my timer gone off? Cancel that. So, and I've just gone off my email. See, old people and technology, not a good combination. Okay, so quick stream question. For perspective drawing, how do you figure out the angle of a slanted roof? Because it's not a strict horizontal line. Okay. How do you figure out the angle of a slanted roof? Okay, so I'm going to draw a few lines here. So let's draw it on the horizon. So I'm going to draw a building. Vanishing points. And let's make that roof go up to there and down to there and vertical line. And then I've got my same problem with ruler not being long enough. Should have invested in one of those yesterday. Okay, so a building like that. I probably should have done that looking from the top so I could see over the roof, actually, thinking about it. So I'm going to completely scrap that and start again for the benefit of mystery student R. So 2 vanishing points. I've got a horizon line there. I've got squares in the book anyway, so I don't especially need to draw the horizon line. Okay, so let's make the corner of the building down there, and then sides of the building going towards a vanishing point. I'll stop them there at that vertical line. So the bottom is going to stop at the same vertical line. So I'm kind of drawing the front 2 visible walls of the building. Let's say that there, and have this one stop at the same vertical line, and then vertical line there. And then beyond this, there's a whole bunch of stuff that you can't see. So there's back walls that are still going towards the same vanishing points. So you can sort of pencil them in so that you've got them there as working lines, even though you're not going to put them permanently in your drawing. So kind of like that. And what have I got? One over there. One over there. So you can sort of pencil in where all the bits are going to go that you can't see. So I've got a kind of back base there. I'll do this in a dotted line. Like that. And I've gone off the line. Whoopsie doopsie. And if you do this accurately enough, which is a bit difficult with the thick pen, then the back should come out perfectly vertical. Mine's a bit wonky because my ruler wasn't long enough to do it accurately, but should have come out perfectly vertically. So the question from Mystery Student R is, if I'm doing a sloping roof, how do I know what the angle is going to be? Well, how it appears, I mean, how it would appear in a photograph would depend on distortion according to the curvature of the lens and all sorts of things. But what you can do is figure out the space of a rectangle that it would occupy. So, for example, if I divide that into units and then further subunits by diagonals, then I can figure out how many more of those diagonals it would take me to get up to the top of the roof. Because wherever that roof peaks, it's going to be enclosed in another rectangle, or distorted rectangle, I should say, and everything in that rectangle should go to the same vanishing points as before. So imagine it like a shoebox with a lid on. So you can kind of draw the lid on the shoebox as well as the shoebox itself, with everything going towards all the same vanishing points that they did before, including the back, not all of which you can necessarily see. Yep, so use all the rules that you've got so far to draw a shoebox with a lid. I've gone too far of that. And using all the same rules, you can figure out where the back of that lid is. Yeah, so if you can imagine that as a shoebox with a lid, and you can see this front bit, but you can't see the back bit, but you do know where it is, then I'm going to color this. Can we see that coloring? Not at all. I wonder whether I've got a highlighter. Red pen, that might do the trick. Yeah. Okay, so the front and back of my shoebox lid, I can figure out where they are. And then my sloped roof is going to be contained within those. And I know how to find the middle because I can just draw across and then a vertical up to see where the middle is. And then I can do the same on the back one. So draw across to find the middle, and then a vertical up to find the top of the middle. So these two dots that I've drawn are going to be the peak of my sloped roof. So they're going to join up along the very top of the building, and then they're going to slope down to the two tops of this side rectangle. I say rectangle, it's a rectangle in real life, but it's distorted on the diagram. So I can certainly figure out where the roof goes, so that the back and the front are right for each other, and then there's a further slope here, so my roof is there, and then you can't see the back. But as far as how to draw that angle and make it look accurate, not easy, but just think about the rectangle or the distorted rectangle that sloped roof occupies, and then construct that first. I hope that helps. Oh, and another one. Can I do a quick recap on simultaneous equations? Here's a specific one from my iMaths. Well, it's great that I'm getting all these actual live queries now, even though there's only 2 viewers, and one of them I think is me. So hopefully mystery student A from MYP5 is watching. So let's do these simultaneous equations. I've got a nice video about these on my YouTube, actually, if you have a dig. Minus C plus 2D equals minus 30. I'm almost certainly going to have to give myself more space than this, I think. So let's go over here. Let's try the smaller pen. Okay, so minus 3C plus 2D equals minus 30. 6C, minus, I should have written, minus 7D equals, zoom in, 78. So we've got to figure out what C and D are. So the whole thing with simultaneous equations is those are a pair. I'm going to label them 1 and 2. The whole thing is we've got to figure out a value of C and D that works in both. And a classic way of doing that is by elimination, which means making something the same in both equations. So here I've got a minus 3C and I've got a plus 6C. So I notice that 3 goes into 6. So if I multiply equation 1 by 2, instead of being minus 3C plus 2D equals minus 30, I'm multiplying everything by 2. So I get minus 6C plus 4D equals minus 60. So I'm going to call that equation 3. And meanwhile, equation 2 is just the same as it was before. 6C minus 7D equals 78. But I'll call that equation 4, even though it's the same as equation 2. So what I've done there is I've made the C's, well, almost the same. I've made one the positive and one of the other and one the negative. No, what am I talking about? I've made them positive and negative of the same thing. So I've got a minus 6C here and a 6C here. So because they're plus and minus the same thing, then if I add the two things together, then the plus 6C and the minus 6C cancel each other out. So what I'm doing is adding whole equations together, just to be clear. I'm taking the whole of equation 3 and adding the whole of equation 4 to get minus 6C, add 6C, nothing, disappears. 4D, add minus 7D, makes minus 3D. And minus 6D, add 78, makes 18. So minus 3D equals 18. I don't want to know what minus 3D is. I want to know what D is on its own. So I'm going to divide everything by minus 3. So 18 divided by minus 3 is minus 6. So we figured out that D equals minus 6. So now that I know that D is minus 6, I can substitute it back into the original equation 1. So I'm going to take the original equation that I started with, which was minus 3C plus 2D equals minus 30. And now that I know that D is minus 6, sorry. Now that I know that D is minus 6, then this 2D bit becomes 2 times minus 6, which is minus 12. So that becomes minus 3C minus 12 equals minus 30. So I'm trying to figure out what C is. So I'd like to get the C bit on its own. So it's quite easy to get rid of the minus 12 by adding 12 to both sides. And then you just get the minus 3C bit on its own. But then I've got to add 12 to the other side. So minus 30 add 12 is minus 18. And then I get minus 3C equals minus 18. So I don't want to know what minus 3C is. I want to know what C is on its own. So I'm going to divide everything by minus 3. And I've got to do that on both sides because it's like a balance. So minus 18 divided by minus 3 makes plus 6. Minus divided by minus makes plus. So C equals 6 and D equals minus 6 are my answers. And then it's good practice just to check that in the other one of the original equations that you didn't use. So 6C minus 7D equals 78. So that becomes, so I know that C is 6, so 6 times 6 is 36 minus 7D. So that's 7 times minus 6 is minus 42. So I've got 36 minus 42 equals 78, which is correct because minus makes plus. So I know that I've got that one right. So as it happens, I did that by making the C's plus and minus the same thing, and then adding the equations to cancel them out, because that happened to be easiest in this particular question because you had a plus and a minus. But in another question, it might be easier to make them both exactly the same, and then you'd be subtracting to eliminate the things. I suggest you do dig in my YouTube channel and have a look for simultaneous equations, because there is certainly at least one good video in there with lots of examples. Okay, so let's see if there's any more. Oh, well, thank you as well. That's lovely. So, no more messages other than the thank you from student R. Okay, so running back on my pad, I can see we've nearly been going an hour now. And let's just try to find my list of things I was going to do. All over the place. Here it is. Okay, so we've done Pythagoras. We've done a bit of fractions. We've certainly done some requests, and that was great to get some this time, just to know that there's somebody out there. So I think I will call that a wrap for today at 8 minutes to 1. So we'll leave that there, and we'll see you tomorrow. Do email me with any requests you've got, and yeah, tune in next time. Just going to leave a little message for anyone who tunes in now. Back tomorrow at 12. Have a great day and keep working hard.